Hey, what's up, guys? This is Chung here. So today, let's take a look at LeetCode number 945, minimum increment to make array unique, right? So the description is pretty short. Basically, you're given like array of integers, and so a move means that you need to basically choose any number and increment it by one, and your goal is to make the array unique. Basically, each number is unique, and we need to find the least number of moves to make uh, every value in the array unique, right? So we have some examples here. For example, one here. We have input 1, 2, 2, right? I mean, so the output, the move is one. Basically, because we only need to change this 2 to 3, so that I know we have 1, 2, 3, right? And now we have example 2 here, right? So let me open the drawing tool here. So here we have this array here. The output is 6 because we need 6 moves, right? Because we have 2 ones, right? So which means 2 ones, 1 1. Of course, if there's like any duplicate numbers, we have to increase, right? Some of some of the numbers there. So we need to increase this one to 2, and then we have 2 2s, right? So which means that, since we have 2 here, from 2 and 2, we also need to increase this 2 to 3, right? And this one increase to 4, right? And then we have 7, right? That's why, the total increment is what? Is 1 plus uh oh, did I miss a different number here? Oh, we also have a 3 here. Okay, so we have a 3 here. So with 3 here, since we already have 2, 3, 4, which means that we need to change this 3 to 5, and then we have 7, right? So we have 1, 1, 2, and 2, right? That's why the total is 6, right? And the constraint is like 40,000, and the number range is also 40,000, right? I mean, you know, there's things we have already like actually find out like the first approach, which means that the first approach is that we can simply just sort this array, right? We sort it from the smallest to the biggest, and every time when we see a current numbers, we compare with the biggest number previously set up, right? Which means that starting from the second one, right? And then we have a pre. This pre means that actually it's the biggest number uh, we have seen so far, right? So at the beginning, the pre equals to 1, right? And now we have 1 here. Since the current one is either equal or smaller than the previous one, which means that we need to increase it, right? So, but how many moves we need to make? Basically, we just need to use the previous one, right? Minus current number and plus 1. That's going to be the total number of increase we need. And then every time when we finish processing a number here, we also gonna need to update the pre, right, to the what? To the current biggest number. Right? That's why, now we have 1 here, the pre is also equal to 1. That's why we need to change this one to 2, right? And after this one, the pre will become to 2. And then we have another 2 here. So which means we also need to change this one to 3 because 2 is also smaller or equal to 2, right? That's why we're going to change this one to 3, right? Now we see another 2. Since 2 is also smaller than the previous one, we're going to change that one to what? To 4, right? And so on, so forth. And then when we add 7 here, since 7 is bigger, it's greater than the previous one, than the previous number, which is 5. That's why we don't need to do anything for the last number, right? So yeah, so that's basically the first approach, which means we simply just need to sort the array here, and then we also maintain like a previous max number, right? And yeah, let's try to code that. And all right, so we do a dot sort. Okay. Oh, and notice that the length can be 0, right? Which means that empty array is also like a valid scenario, so that we can simply just check that separately. When this one is not, there's nothing, we simply return 0, right? And then we sort. We have a pre. Pre is going to be starting with a0, right? And then we have an n equals to length of a, right? And then we have the answer equals to 0. And like I said, we start from the second one, right? Which means it's going to be the 1 to n, right? So we have current. Current is going to be the AI, right? And so if the current one is equal or smaller than the previous one, right? We do what? We need to increase. Basically, we need to increase the current number, right? By some moves, right? But how many of those? How many increase we need to make here? So we need to make the previous one, like I said, minus current plus 1, right? That's the moves we need to make, right? If the current one is not greater than the previous one, otherwise we don't need to do anything, right? We can simply just update that previous one, right? Just like how we handle the 7, right? So after this one, right? I mean, if we're still trying to use the current to update the previous one, we also need to update the current one, because the current one also needs to be updated, right? So the current one gonna become what? Gonna become the previous one plus 1, right? Because the current one means that since the current one is smaller than the previous one, it means that we have to use the previous one as a base to 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 calculate the current one, and then we also accumulate the moves we need to do to make this current one a unique number. Cool. And yeah, so that's it, right? I mean, we simply just return the answer, right? In the end, because so I mean, there is like a little bit of greedy idea here. Basically, we so the way we're trying to use the least number of movements is that we only increment it in a way that it can be a way that we don't need to increment it, as I mean, to a very big numbers. As long as every number is different, we're fine, right? That's why we're trying to increment it like from the smallest to the biggest, so that we're not wasting any of the moves here, right? And yeah, so that's it. So if I run the code, so accept it, right? And then submit. Yeah, cool. So works, right? How about time complexity, right? I mean, obviously we have a sort here. So if the length of a is n, so the time complexity is going to be n log n, right? And the space is, I would say space is 1, right? So the time complexity is n log n, space is 1, because we're not using any of the, we only use this like pre variable, right? Yeah, so that's the first approach. And so can we do a little bit better than the log n time complexity here? Since we haven't used the second constraint here, which is the range of the numbers, if we use that one, basically we can simply loop through all the possible numbers from 0 to the end, right? So which means that, and so now here, we also do it from in the incrementing order here, So if we know the range, right, I mean, we can do the similar thing. And the only thing left is that we just need to know what's the frequency, basically what's the count for each number. Because, let's say we have uh, 4 1s, and then 3 2, and then 4 2, and 4 3, and so on and so forth, right? So let's say we have this kind of numbers. It doesn't really matter like the sequence, because we're not doing the sortings, because we use the range to try each of the number. And at each of the number, if we see like a count, right? Because, for each of the count here, let's say we have 5 2 here. We know for the duplicate numbers here, we have to increment the remaining ones in an incremental way, so that, at least for this group of numbers, they're gonna be distinct numbers. So which means that, what does it mean? It means that if all the numbers are 2, right? So for the second one, starting from second one, this one will become to 3, right? And this one become to 4, and this one become to 5. The last one is 6, right? So this is the numbers we're going to change to. And how about the moves? So we have 1, 2, 3, and 4, right? So that's going to be the moves we need to make, right? On the to at least to make the current group unique, right? But, this is assuming, we're not changing the base, which means that the base is still 2. But for the scenario that, if the previous number is also greater than 2, maybe 2 is not a good number. It's not a good example here. Let's say this one maybe we have 8, right? We have 8. So this one will be changed accordingly, but, the moves are the same, right? So so this 1 2 3 4 is based on we're not changing the base, which means the 8 is fine. But, what if the previous one? What if the previous one, the previous biggest number is 10? Because which means that we already have some other duplicate numbers before 8, and after the process, the biggest number we have is 10, which means that, at the current numbers here, instead of 8, we have to start with what? Start from with 11, right? That's going to be the base for the current one instead of 8. So what does it mean? It means that, on top of this 1 2 3 1 2 3 4, we also need to add another some other moves. So what are the moves? Basically, how many? That's the moves is going to be the number the number of the count for the current number, which is 5, times what? Times the difference, which is the 11 minus 8. That's the second part of the movements, right? And yeah, so now we have the formula here, and for this one, that's the basically that's the sum, right? That's the sum from 1 to 4, right? So what is 4? 4 is a count. This is a count minus 1, right? Because we have count is 5, and the biggest number we're having here is 4, right? So this one is everyone knows the formula: n times n plus 1 divided by 2, right? Yep, so that's basically the two parts of the movement. And for the second solution, right? And yeah, so I'm going to do this coding real quick here, okay. Okay, cool. So we need to do a count, right? So the count, I'll be using a counter. And So we have answer equals to 0, right? And what else? And we have a pre, right? Pre is going to be starting from 0, maybe. Actually, the pre should be starting from -1, because we'll be comparing the current one. If because the number is in the smallest one could be 0, So that's why we start from -1 here. And so to loop through the range starting from 0 to we can simply do a 40,000, but that would be a waste of the loop here. We can simply do a what? We can simply do a max number of a. That's going to be the upper bound of our loop here, right? So we can simply do a for number in the range of max plus 1, right? And we have current. We have count, so the count will be the count of the current number, right? And then we check if the count is greater than 0. That's when we need to do some work. Otherwise, if the number doesn't exist, we simply skip, right? And we just I'll define like total moves, right, for the current group of numbers, right, to make the current group of numbers unique. Okay, so at the beginning it's going to be 0, and the max move, right? So the max move is what? Like I said, is count -1, right? So like I said, if we have 5, 8, so we need to change. So for this one, we change it to 1. The move is 1. The second one, we need to make 2 moves, and 3 and 4. So that's why the max move is what is count -1, which is 4, right? Because I'm going to use this one to calculate those total moves. So the first part is, like I said, is n times it's the sum, it's the total for this part, right? It's going to be the max move times max move plus 1, and then divided by 2, right? And okay, so and then I'm going also need to use this max number equals the number plus the max move, right? So I need to use this max number to get to update this is pre, because for every loop here, I need to know what was the max number we have seen so far, right? So that's why the max number at the beginning, just looking at this group of numbers, the max number is what is the number 8 plus the maximum, which is 4, is 12, which means the max number is 12. But this is only considering this group of number itself, right? But we also need to consider the base, right? Check the base of the current number, right? Which means we need to compare if the number is either equal or smaller than the pre, which means that if the pre, like I said, if the pre is equal to 10, right? So this is when we need to update both of the total moves and the max number, right? So first, the total moves will be increased by the count times the pre minus current number plus 1, right? Which means we have 5, 5 times what? The pre is 10. 10 minus current number is 8 plus 1, right? That's why we have this formula here. And then similarly for the max numbers, it's going to be increased by the pre minus num plus 1, because the max number in this case, instead of 12, it'll become to what? To 15, just because of the previous one is greater than the current number. Now we can simply we can update the answer, right, by the total moves, and then we also update the pre with the max number. Yep, so that's it, right? So now I simply just need to return the answer here. Update, right? Update the base, yeah. So run the code, accept it, and oh yeah, this a corner case here. Cool. Yep. So this one also works, right? So I mean, as you guys can see here, so for the second approach here, the time complexity is simply O of n, right? Because we are not doing the sorting here. We simply do a count and the max. That's a 2 O of n, and then the for loop is also O of n, right? So in total, the time complexity is O of n. But space in this case is what? Is also O of n, because we need this count to store the frequency for each number. Yeah. Cool. Yeah, I think that's it, for this problem. And yeah, thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.